All right. Good good morning from my end here. So today will be the first class for the last week, and we'll be looking at functional programming in Python. So we talked about user function definition the last time. I think is during the second week. I treated functional definition or user definition, user functions, right? Where you have to define your own functions and see how you can make use of them when you're working with when you're coding. So for today, I'll be looking at functional programming. So what does functional programming entail? Functional programming are just set of programs that have been built in Python. So they are usually inbuilt programs, right? So I would like to share some of them. And the major one is usually the lambda function. The lambda function. So the lambda function uh is seen as an anonymous function, right? So one thing that lambda function does is that it's usually anonymous. Why is it anonymous? Is because you can use it anywhere. You can use it anywhere. And another thing is that these functions, when you want to define them, you define them using the keyword lambda. Lambda. So they are useful for short, right? Throwaway functions where defining a full function will be overkilled. Let me explain. They are useful for short execution of code. So if you want to have, like, let's say just two lines of code to help to do something for you, right? And then you know that if you're using a user-defined function, it might cost you more than two lines of code, right? So in that scenario, it will be best you make use of a lambda function. Why do we use lambda function? Because it is very, very short, right? And then a throwaway function, throwaway function. So uh, it displays the normal user-defined function in a way that because it is short and it is also effective, right? It is effective. So it will help display the other long function that most times might run into an error in cases where you're trying to build the code. Then we have example of how the syntax is being written. So this is it. You define lambda and then the arguments you want. The arguments are usually the parameters, right? Remember when we're doing user function, you define you define the function name, and then you write your definition, the function name, and then open and close a bracket for your arguments, right? And for this one, we'll have lambda, arguments, and expressions. So the argument is the variables. And while the expression is what you want to execute or is the task you're giving to the function lambda. All right. So I think that explains it fine. So let's look at an example here. I have a lambda function to add two numbers. So we have total, we have lambda x and y, right? And then x plus y. So if you look very closely, let's take this guy up. All right. So we have this to be, this is our lambda. Look at this. I'm just, why I brought it up is for us to see how the syntax is. So this is the lambda. These are our arguments. X and Y are our arguments, right? And then you have your column. What separates your arguments from your column is usually the argument from your expression is the column. Then thereafter, you now have what your expression. So this expression is an additive expression, right? So because we want to add two numbers, x and y, we are now saying that lambda x comma y, x comma y is our what? Our arguments, while x plus y becomes the expression. So total will be equal to what? Lambda x plus xy rather, then column x plus y. Then when you want to get your results, mind you, you cannot get your results with this guy, because Python will always require a value for x and y. So for you to get that value, just like we did when we're doing our user-defined function, you realize that you have total, open bracket, 5 and 6, right? Sorry, 5 and 3. And then when you run this program, you'll be having what? 8 to be your result. So we can as well have cases where, let's say we have lambda coming, okay? Let's check out 1 or 2. So what if we have just one argument, then we are adding that to 3, or rather to 6, and let's call this num, right? So I can now have that once I run this guy, I can have here none, open and close brackets, right? Oops, that didn't go well. It shouldn't be. I think it should be okay. Let's bring up this guy. Okay. So I should be having, I want to make use of this values. That's why I'm trying to bring them up here. All right. Okay, so I have none 3, right? So if I should run this guy, I should be having what? 9, because x becomes my argument, while x plus 6, that x, so I have now give it a value to be 3, and x plus 3, 3 plus 6 will become what? 9 as our output. So there's another inbuilt function known as map. The map function applies a given function to each item of an iterable and returns a map object, an iterator, right? So we'll definitely have a list. And then in that list, what map will do is that it will try to um it will try to apply a given function to each of the variable, or sorry, each of the item in this iterable list, right? And then it will now return a map, which is actually the result of the result from that given function, right? So let's say this is a syntax actually, where you have map, open and close, open a bracket, the function you want to work with, and then the iterable, right? All right. So let's look at this now. We have a list of integers, or let's say a list of, yeah, just like the example we have here, a list of integers from 1 to 5, right? And then we want to double this integers. When I mean double, we want to get the squares of each of the, not the squares actually, we want to double it, multiplying it by 2. So to double it, we'll have that this list is just to ensure that everything we are doing is being contained in a list, right? But this is where the main thing happens. Map, right? Lambda x colon x times 2. So this is the function now. Lambda x. X is now our what? Our argument. And then x times 2 becomes what? What the expression. So the entirety of this lambda x colon x times 2 becomes what? Our function. And this numbers is the number we have declared here, right? So when you print doubled, it should give us what? 2, 4, 6, 8, and 10. But the original number was what? 1, 2, 3, 4, 5, and that, right? So we have been able to double this guy without writing a long list, right? So all of this can even be done in just 3 lines of code. But you remember when we're doing loop, that when we say for this in this, right? But what Lambda and Map hasn't been able to do for us, it has been able to reduce and cut short some of the processes we should have gone through. So that is the beauty of Lambda and uh, Map. That is clear enough. And then, so this is how it works. Let me explain this one now. So what this lambda would do is, what this function would do is that function is telling you that once a value x, multiply that value x by 2. Then what map will do is that map will come to these numbers, right? These numbers now, and we'll pick one per time. When it picks one, to take it to this expression, multiply it by 2, put it into this list. That's why you're having it here. It becomes 2. It goes again, pick the second one, come multiply it by 2, send it into this list we brought here, this list guy. It will now give us what? 4. So that is just how it works. Then we have also filter. The filter function filters elements of an iterable based on a condition defined in the function. So it actually filters elements, like it sieves out elements with respect to the function that has been declared or defined in, or rather, with respect to the condition that has been defined in that function. So here is the syntax. We have syntax filter open brackets, function, then the iterable, right? So this function here is what is regarded as what? The condition, while the iterable is the list or the containment where the iterables are. So when we refer to iterable, it means that it's actually a data structure where we can have more than one items inside of it, right? So filtering even numbers from this particular number. So once we filter even numbers, and how do we get even numbers? Even numbers are numbers that when you divide them by 2, the remainder will be what? 0. So we can now, with that idea we have, we declare list filter. This is lambda now. So lambda, a variable, x, colon, x modulo 2, right? Being equal to what? 0. So this is a test condition. We are testing if we divide x with a model ratio. Remember, model ratio should always return what? A remainder. So if we do the model ratio of each of these items in this list, and the model ratio is giving us a result to be equal to 0, such an item is what? A list. Sorry, an even number rather. So if it is an even number, send it to this list that is known as evens. So when you print the even numbers, you realize we are having what? We're now having 2 and 4 in our even numbers. Two and 4 in our even numbers. So that is as simple as that. So let's see another function that works with lambda, the reduce function. So what does the reduce function does? The reduce function available in function tools model. So this other guy is looking like a third, I would say a third party, right? But not really. What I mean is that you have to what? Import it from a module known as functools. And then it applies a rolling computation to pairs of elements in an iterable. So just like all other functions I've talked about, this is the syntax now. Reduce function this by this, right? Okay, let's look at this very closely. So we have calculating the product of all the numbers in a list. So we have a list here of numbers, right? And then the product is being equal to what? Reduce it to what? Lambda x, y. So x times y becomes our expression. So it will multiply this by this. This will now become our x. Then the one in front becomes your y. It will now multiply by the next one, by this, until it gets to the end, and it gives us an output known as 120 to be the product of the entire list. So if you run this, 120 should become the solution. Why is 120? Why is it just one number that is appearing? It's because when you multiply 1 by 2, it should give us 4. Sorry, 2. And then you multiply 2 by 3, you're having 6. 6 by 4, you're having 24. And then when you multiply 24 by 5, you're now having what? 120. That is why we have one result output. So we have a practice task here. data processing with Lambda. So we have to write a program to process students' grades using Lambda and functional programming techniques. So the problem statement, we are given a list of students' grades to perform the following: to add 5 points to each grade, filter out grades below 50, then compute the average of the remaining grade. So basically, because we are adding 5 to the bonus of each, we'll make use of what? Map. And then when we are now filtering, make use of what? Filter. Then when we are computing the average, we make use of reduction. So this is all what we did. And then when you run this code, you run the answer, you'll be having original grades to be what? 45. So this is the original grades of the students. And then when we added 5, this is the grade after the bonus mark was added. And then the passing grade is this guy, right? Anyone above 50, equal to or above 50 will be this. Then the average passing mark should be this. The average passing mark is when you've done what? You've added the entirety of the passing grade, right? And then you divide it by the number of passing grades. It's just like when you're calculating our CGP, our GPA, rather. So that is basically what we have on the functional programming in Python.